Here's an explanation of some of these SN2 reactions. So, first of all, the mechanism for this reaction is SN2. And remember that when you have a chiral center and the nucleophile comes in and does the backside displacement, that in an SN2 reaction, we end up with inversion of configuration. So if the original chiral center attached to the leaving group started out R, it becomes S, and vice versa. Now, actually, in this particular case, we don't have to determine whether it was R or S to begin with. We just have to understand how the attack is going to occur. So first of all, here we have our secondary alkyl halide with the bold wedge, and then the hydrogen is there. Our nucleophile, if we ignore the counter ion, is CH3S minus. So that's our strong nucleophile that's going to come in and do the displacement. So when the CH3S comes in and attacks the carbon and kicks the bromine out, in a molecule like this, what will happen is that we will have 100% inversion of configuration. And the product then will we will replace the Br with an SCH3. The only question is, should it go on a bold or a dashed wedge? Well, to invert the configuration, that sulfur would have to go on a dashed wedge, and the hydrogen would then go on a bold wedge, which would then lead us to product 2 would be the major product of the reaction. Now, if you're looking down here, what you see is that they added the CH2 with the SH, and that is not what the nucleophile is. The nucleophile is an Na plus S minus, and so this is our nucleophile. Now let's double check and make sure that we're right. So looking at the original product, hydrogen is 4, bromine is 1, this carbon versus this carbon. This carbon over here has 2 carbons and a hydrogen attached to it. This carbon over here has 3 hydrogens. So this would be group number 2. This would be group number 3. So going from 1 to 2 to 3 is counterclockwise, so that chiral center is S. So in our product, the chiral center better be R. So if we look over here, we have our 4 groups. Let me go ahead and take those out of the structure, and we'll just write the numbers. So in this case, number 1 group is sulfur. Number 4 group is hydrogen. Number 3 group is the CH3. And the number 2 group is the CH with the 2 CH3s on it. Number 2. Is 4 pointing away from me? No, it's not. So now I need to switch groups 1 and 4 and groups 3 and 2. So I just did 2 switches. Going from 1 to 2 to 3 is now clockwise. And so this configuration is the R. So we are correct. Product 2 has the correct nucleophile added with the correct stereochemistry. In the follow-up question, it asks, what about this problem? And so in this problem, we're going to do the same thing. Only in this case, they asked, does the product of the given reaction, is the product R or S in its stereochemistry? So let's just go ahead and write the product and see what we get. So here is the original molecule. Whenever you don't see the hydrogen, look at the molecule. We'll always have 2 bonds in the plane and then a bold and a dashed wedge. So if you're missing the hydrogen, it has to go on either the bold or dashed wedge, whichever one is not shown. Okay, what's our nucleophile? Well, we have an Na plus Cn minus. The Cn minus is going to be the nucleophile that comes in and attacks the carbon and the bromine leaves. Again, this is going to go by inversion of configuration. That means our product is going to have the Cn on the bold wedge with the hydrogen on the dashed wedge to show that inversion of configuration. Now, let's do the R and the S just to make sure that that's the case. So over here in the product, I'm going to write my molecules, or I'm going to write my bonds in their orientation. Hydrogen is number 4, bromine is number 1. CH3 is versus a CH2 with a carbon attached to it. That's going to be group number 2, the CH2 with the carbon versus 3 hydrogens. Now, is the 4 group pointing away from me? No. I need to switch groups 1 and 4, and then groups 2 and 3. So now going from 1 to 2 to 3 is clockwise. So the original stereochemistry of the alkyl halide was R. This means that if this is truly an inversion of configuration, because this is an SN2 reaction, in this case, this should be the S configuration, but let's just double check. Okay. So what we have is we have hydrogen as 4. I have carbon versus carbon versus carbon. This carbon is a CH3, so it has 3 H's attached to it. This carbon is a CH2 with a carbon attached to it, so it has 2 H's and a C attached to it. This Cn is a C triple bond N, so its equivalent structure is a C with 2 N's attached to it. And then the N has 3 C's attached to it, so 1, 2. So for the carbon, it has 1, 2, 3 N's. That's the equivalent. For the nitrogen, it has 1, 2, 3 C's. That's the equivalent. Either way, this is a carbon with 3 N's attached to it. So who wins high priority? Cn, followed by 2 hydrogens and a C, followed by 3 H's. 4 is pointing away from me. Now going from 1 to 2 to 3 is counterclockwise. So this is the S configuration. We do have inversion of configuration, and so B is the correct answer. So for these problems in chapter 7, again, we're doing SN2 reactions, and so that means that all of the reactions will go by inversion of configuration.